Hey guys, how's it going out there? Welcome to the show. As usual, if you'd like to support this channel, there are PayPal and Patreon links in the info box below. Got a great one lined up for you tonight, folks. We got flat versus flat debate. Want to welcome Witsit. Gets it? How's it going out there, sir?
Pretty good. How are you?
Good. Fine. And Brian's Logic.
Hey QE, hey Austin, hey everybody. Thanks for coming along.
Outstanding. We're all good to go on here. Looks like the stream's going well. Got a fine audience out there. All right. We wait for a couple minutes. Everyone get comfortable. Get their drinks. Anything new out there, gentlemen, or are you ready to go for it?
Yeah, I'm ready whenever you are.
Okay.
Is this live? Yes, it's live. What's up, Unicorn Laser Eyes? All right, all right. Let's get it on. Welcome to the debate between Witsit Gets It and Brian's Logic. As you already know, we've, that is, flat earthers, have pummeled and mule-kicked gravity into the incoherent oblivion. These fine gentlemen are going to offer their case for explaining the cause of that effect, something that has never been demonstrated before. The most important thing, the goal of the debate, is to get to the truth of the matter. Be a rigorous scrutiny of the underlying tenets of the arguments presented. It's not about the messengers here. It's not about Brian. It's not about Witsit Gets It. It's the message and the veracity thereof. It's solely and squarely in focus. Now, I will moderate the debate only. That is, I will not get involved in supporting or defending either position. Only admin. Each debater will have a 1-minute-ish introduction, bio, favorite color, etc., position they're defending. After the intros, the challenger, Brian, will begin claim, then support. We'll alternate claim and support thereafter. No gish galloping. That is a barrage of multiple claims in rapid succession. Ain't gonna happen. One claim at a time, clear and concise, as possible. Don't ramble incoherently. Followed by support for that claim, i.e., scientific, logical, demonstration, etc. Screen sharing will be activated and engaged upon request. When finished supporting that single claim, just say done or finished. I will then request rebuttal. For example, Witsit says done, I'll say Brian, rebuttal, sir. Rebuttals follow the same rules as the claims. Clear, concise, and supported. 3 rebuts max to a single claim. For example, Brian makes a claim, Witsit rebuttal. Brian rebuttal, Witsit rebuttal. Then Brian has the final word. Then Witsit, next claim. As mentioned previously, claims will alternate between Brian and Witsit. No over-talking, or I'll mute the hangout and instruct the bailiff to whack some peepees. All right? No over-talking. That ain't going to happen. Objections are in force. If either member feels that their position or argument is mischaracterized, logical fallacy employed, etc., at any point, you just state objection. The debate will stop. That means shut up in this. I will then restate objection. The objector will then support his objection clearly and concisely. I will then rule on that matter. If the objection is upheld, the guilty party will either drop or reformulate the point. At the end of the debate, close out. Both Witsit and Brian will have 2 minutes each to restate their positions and summarize. There will be no backbiting or color commentaries about the debate. After closeout, a Q&A session will ensue between the audience and debate members. You can super chat your questions at any point during the debate, starting now. I'll go through each question in order they were received, when ready. Any questions, comments I deem illegitimate will not be aired, i.e. ad homs, insults, heckling, backhanded or forward-handed slights, foul language, and such. Any questions?
Negative.
Brian, any questions?
Nope.
Let's get to the introductions. Brian, you're first. 1 minute-ish. Go for it.
Okay, thanks, Huey. My name is Brian. My YouTube is Brian's Logic YouTube page. I'm a flat earther for 5 years. I am supporting tonight the law of relative density equilibrium. I believe that it is a natural thing that happens all the time, and it is the reason for the vectors that matter takes, whether down or up. And I know that Austin has a different view on it, and that's why I asked Austin for the debate tonight, and he agreed, which I'm very happy about. And that's about it. Thank you.
Witsit, sir.
Yeah, my name's Austin Witsit. My channel's Witsit Gets It. My favorite color is royal purple. And yeah, of course, I don't dispute the role that density has in the effect, the observable phenomenon of downward acceleration. But to be more specific, I say that what's falsely attributed to gravity is incoherent dielectric acceleration. So yeah, let's just get into it.
That was quick. Outstanding, gentlemen. All right. Since Brian challenged Austin, then Brian is first up. Like I said, we will alternate claims and support. Off you go, gentlemen.
Okay. Thanks, QE. Okay, I'm going to start with a small bit of reading, and then I'm going to show a video, a part of a YouTube video that you'll all be aware of. And after that, I would like to ask just 2 questions to Austin, and then Austin is free to challenge back or to move on to his own topic if he likes. Is that okay?
Yes.
Okay. Okay, I'll start. I'm just going to screen share. I should be coming through there now. Am I, QE?
You're getting there. Go ahead.
Okay.
1 second. 1 second, please.
Okay. What is the difference between a colloquial theory and a scientific theory? This is of the utmost importance now in the world more than ever before. A colloquial theory is a generalized theory on anything from why did your fridge stop working to what creates a rainbow. I know that we kind of already have an explanation for a rainbow, but I just threw that in there because at one time it was a colloquial theory. It is something that has not been put through any scientific method of inquiry. It is open to interpretation and change. Whereas a scientific theory has a very definite definition, it is a theory based on a naturally observed phenomenon that has had its positive hypothesis proven correct and its null hypothesis proven incorrect when put through a hypothesis test. What is a hypothesis test? Hypothesis test is a scientific experiment that adheres to scientific method strictly, so as to make sure that all outcomes are honest, repeatable, and true. So what are the steps of this method? Step 1, observe a natural phenomenon. This is the observing of something in the natural world that is not understood yet. Step 2, state your positive hypothesis, what you believe to be the natural cause to the naturally observed effect you witnessed. Step 3, state your independent variable, that which you will manipulate during the experiment, your presumed cause. Step 4, state your dependent variable, that which you expect to see by manipulating your IV, your independent variable, the expected effect. Step 5, state your control variables, that which you intend on keeping constant and unchanging during the experiment. Step 6, state your null hypothesis, that which is the polar opposite of your positive hypothesis. Step 7, perform your hypothesis test to determine whether your positive or null hypothesis is correct. Step 8, state your final results so they can be reviewed, repeated, and demonstrated by others to confirm your results as true, honest, and dependable. Okay, and now I'm going to share the video. This is going to be this null hypothesis, that which is the polar opposite of your. Sorry about that.
Yep.
Okay. This I couldn't mute that QE. Sorry, because I was waiting for it to start.
That's okay. You're good.
Yeah. Okay. So this is Anthony Riley's egg experiment. So his phenomena, his natural phenomena, was things appear to float, sink, or be suspended. The hypothesis is if he changed the medium's density, the egg will move. Okay. His null hypothesis is if he changed the medium's density, the egg will not move. Okay. Just move on there to his. Now. So his independent variable is the density of the medium, and his dependent variable is the egg will move. Okay. So I'm going to cut out as much as possible. I'm just going to go straight to the most important part of this video, which is right here. So just to give a bit of background, anyone can watch this. Over on the left here, he has already made the egg move in the saline water by bringing it from the bottom. Once he stored the water, he brought the egg from the bottom, because it was salt at the bottom of the glass. He brought the egg from the bottom up to float where it is, where his finger is pointing. Now he's going to add salt, right, which is adding more density to the water, and the egg is going to rise again, which is his positive hypothesis. Okay. Here we go. So as he adds the salt, he's adding density to the medium, and the egg rises. Okay, as you can all see. Now it has risen from its position beforehand. Okay, so that's all I needed to show. Now, all I want to ask, I'm just going to unshare my screen so that it's all before it's all. Now, I'm just going to ask my two questions to Austin. So my first question is do you agree that Anthony Riley performed a science experiment that adhered to the scientific method?
Well, I mean, if he's claiming the causal agent of directionality, then I would have to say no, because density is not being disputed. So.
Okay, but I asked you whether you agreed he did a science experiment or not.
Well, no, he did not manipulate a causal agent.
Okay, I'll ask my second question. Okay, do you agree that he proved his positive hypothesis?
Yes. So you can call it a science experiment if you would like.
Well, he did stick to the scientific method, did he not?
Correct.
And he made his positive hypothesis happen.
Oh, yeah, but he whistled past the actual additional factor that I'm staking. So it's non sequitur.
Okay, so I leave you give a rebuttal then. I go on mute.
Okay. So yeah, of course, when he increased the density of the water, it affects directionality. Once again, this is not being disputed. I mean, you can do this with something as simple as a beach ball. You throw it in the air, it falls down. You put it in water, it rises. So the effect of the density of the medium and its effect on directionality is not what's in dispute. It is the fact that everything's inherently electrostatic, thus the acceleration is dielectric intrinsically. So again, no, I don't think this is a causal agent being demonstrated. Is this simply manipulation of a control variable?
Yes. So how have you verified what you've just said?
How have I verified which part?
That he didn't manipulate a causal agent.
Okay, because the intrinsic in his claim is that the acceleration, which there's an axiomatic law of physics, which could be disputed, but that acceleration requires force. But more so, you then would be saying that density is a force, right? And I don't buy that. All you're doing is manipulating the control variable of the medium itself, which is going to affect directionality. But again, it whistles past the incoherent dielectric acceleration.
Okay, well, I don't claim relative density as a force. I see density as a structural support issue. When he added the salt, he gave more structural support to the egg. The salt, because of its density, was mostly low, between halfway up the glass to the bottom. So he added structural support to the and that gave more structural support to the egg's density. Now, I asked you how you verified how did you verify the cause you're speaking of?
Okay, yeah, that's a totally different question. But so there's nothing to do with the video you showed. But yeah, I can indeed validate what I've showed. It's called a Van de Graaff generator. So you know what that is?
No, I haven't heard of it.
Okay, well, can I screen share real quick?
Yeah, go ahead. Let me know. Go ahead and share screen, and then I'll give you the go when it's up.
All right, cool.
You're good, Witsit?
All right. A Van de Graaff generator is an electrostatic generator which using a moving belt to accumulate electrical charge on a hollow metal globe on the top of an insulated column, creating very high electrical potentials. Whenever we use this, we can actually manipulate directionality. So this is what it is right here. So there you go.
I'm not seeing that myself. I'm not seeing it yet. Just give me a moment and I see it on the watch page. I don't know why I can't see anything on the Sky page. Okay, so you're saying that this Van de Graaff generator, where this can decide what vector something takes.
This is correct. I can actually show a video now that I know you see it. Just
I'm watching it on the watch page, so you can show the video on the watch page, or show the video or watch. Sorry, show the video and I watch it on the watch page.
Okay, so he introduces electrostatic charge. And you see that the paper goes up to the top. This affects directionality. This can be replicated. I don't know if this is showing it very well. But
I'm a little bit behind because it's shown on the watch page, but I'll see it.
Okay, so what this demonstrates indisputably is that the manipulation of the electrostatic charge will affect directionality.
Well, he has to induce this, does he not?
Well, yes, because you're manipulating the causal agent to verify that it causes the effect of directionality.
But what is he manipulating? Is he not adding electricity?
Yes, he's manipulating the electrostatic charge.
Yeah, but what electrostatic charge? I mean, has he added this charge?
Yes, by increasing motion, very minimal amount of electrical charge or electrostatic charge is introduced. This is a manipulation of electrostatics, which is the claimed causal agent of the downward bias.
So you're saying that when he adds electrostatic charge, that it causes things to go down the way?
Yeah, I mean, it's right there. We were all watching it.
Well, I might be a little bit behind because it's not. I'm a little bit behind. I'm seeing it, but I'm not seeing anything happen there. Yes, it's probably going to happen. I'm about 30 seconds behind, I think. Well, the thing about that is he has to add that charge in. Like he has to create this and add this charge in.
Are you saying the charge isn't there beforehand?
Well, has he added charge?
He's increased it, yes.
Or has he added?
He increased it. No, it was already there. Every compilation of matter that exists has a resting electrostatic potential.
Yeah, but has he added electricity?
He increased the electrostatic charge. This is the manipulation of the independent variable.
But has he added electricity from the natural?
Once again, what you're doing in this experiment is you're manipulating the independent variable or your presumed cause, being electrostatics. Once you increase the electrostatics, directionality changes. Now, the density did no way change, right? Density had nothing to do with it. The only thing that was manipulated, the density was the control variable, right? It's the same. But we have manipulated the presumed cause of electrostatics.
Okay, so what you're showing there is, what is that the white thing he has going up and down? Is that a piece of plastic or is that a piece of paper?
Yeah, it's a piece of paper or styrofoam. You can do it with wood shavings.
So he's using. Okay, so he's using small items like that. So you've got to show, right, how when I drop my phone, let's say from my hand, at waist height, and it falls to the floor, how do you show that that is because of this?
How would I show that it's because of this? Because everything that falls to the ground is a compilation of matter, and all compilations of matter are inherently electrostatic. So until you could negate the electrostatics, anything that accelerates to the ground, which is also a compilation of matter, thus electrostatic, would be electrostatic acceleration, more technically and specifically incoherent dielectric acceleration.
Okay. So, so for an attraction to happen, with any electric or magnetic situation, there needs to be a positive and a negative. So, like repels and opposite attracts. Is that not true?
Sure, that would be the mainstream layman. Technically, nothing attracts. It's just pressure mediation accelerates to the null pressure point.
Well, if I have, like, in your claim, the Earth itself has to be either a positive or a negative.
No, it can be, something can be neutral and have electrostatic potential.
Yeah, but how does it attract something then?
Okay, so like another example is if I take a balloon and I rub it on my hair and I increase the electrostatic charge, I can stick it to the wall. Okay, so what I've done is manipulate the causal agent of electrostatics, and it causes it to stick to the wall. Now, as the electrostatics decreases, it falls to the ground.
Yeah, but do we naturally see balloons stuck to walls?
No, we naturally see that everything that's a compilation of matter is electrostatic. We naturally see things have a downward bias down to the inertial plane or the dielectric plane. So you would have to specify contention here. Are you saying the Earth isn't electrostatic? Are you saying matter isn't electrostatic?
No, I'm not denying that there isn't a lot of electric charge, right, in the world. Okay, and our own bodies create electric charge. Take an electric charge out, like can be read off a human body. The brain is basically a conductor, supposedly, which I would kind of agree with. But that's not the point. The point I'm making is you've got to show how when my phone falls out of my hand and it falls to the floor, why that happens. Because I can show that the density of the phone is more than the density of the medium, and the medium doesn't have the correct structural support that phone.
Yeah, all you're showing, once again, is that the manipulation of the control variable of density will affect directionality. I said in my opener that this is not in dispute, right? So if you have a vacuum chamber, all you're doing is manipulating the density. No one is disputing that the density of the medium will affect directionality. We are trying to address what creates the natural downward bias, which you're just skating past with density.
Well, I'm not, but see, this is the problem. There isn't a natural downward bias.
Okay. So you're saying that there isn't a natural down on Earth, up and down?
There is an up and down, but there's not a bias. The only bias towards the down is that there was more things that are heavier, let's just say, more dense than, let's say, the gas oxygen. So anything that's more dense than oxygen is going to go down through oxygen. Right? Even other gases, once they're in a container and kept at and not in a container, left be static and not kept at a constant temperature. There is no, so and anything less dense than oxygen will go up, including other gases.
My friend, you keep looping back to whistling past the point. Okay, so I'm not disputing, my friend, I'm not disputing that density affects directionality. This is indisputable. But the point is that we have a natural downward bias. It's just negligible. The manipulation of a density will far outweigh the electrostatic potential. You're going to have to specify your contention. Is the Earth not electrostatic? Is the object not electrostatic? What isn't electrostatic?
We don't have a natural downward bias. That's not true.
Okay, once again,
are dense, and we live within gas. So things that are dense will fall through gas, as gas cannot support the density of your phone or of most things, even liquids.
Okay, maybe I need to, can I screen share again?
1 second. Let me go ahead and pull it up, and then I'll let you know when you're good.
All right. All right.
1 second.
No worries.
You're good to go?
All right, this is called a gravimeter. Brian, are you familiar with this technology?
Brian, you're on mute.
Sorry. Yes, I was. Yeah, I am. I'm familiar with a gravimeter. Yes, there's two types.
Okay, so can you tell me something that's wrong with the gravimeter?
That's wrong with the gravimeter. Well, the gravimeter has been claimed to be measuring gravity, something that there is no hypothesis or hypothesis test ever done to prove the existence of this gravity. It is purely mathematical. There is an absolute gravimeter and a relative gravimeter. The absolute gravimeter is basically a vacuum tube where they drop a mirror through this vacuum tube. And they also infer a 9.8 meters per second square, I think, calculation into it. And then the relative gravimeter is then calibrated constantly off of this absolute gravimeter. And the relative gravimeter uses accelerometers.
All right, one second.
This is correct.
1 second. Witsit, if you wanted to share, your screen's grayed out. Okay, 1 second. You're back up. Go.
Oh, okay, my bad. I didn't realize if I didn't have it at the top, it wouldn't show. So this is a gravimeter. Now, there's a vacuum-sealed environment inside of this, and they drop, like, let's say, a little BB. Okay, and then using interferometry, they're going to have an intersection pattern, which is going to actually measure the change in velocity of this little BB that constantly gets dropped, picked back up, and dropped. Right. So my question is, are you disputing the efficacy of the technology? I'm not in any way invoking the mathematical constructs of concepts bending and all this nonsense. We all know that the Earth is flat and gravity, as they say it, is nonsense. I'm saying this is measuring, as you said, an accelerometer, right? This is measuring downward acceleration. So do you dispute the efficacy of the technology in any way?
When they are measuring, are they using the speed of light as part of what they call measurement?
Why would they need to use the speed of light?
Well, they're using interferometry, aren't they?
Well, technically, yeah, we do have what's called the speed of light. This is a non sequitur because I don't want to necessarily get into that, but technically speed is travel from point A to point B. I dispute the speed of light or what they call that, but we do know that that phenomena is consistent and we can use it to replicate and quantify. So are you disputing the efficacy of the interferometer?
Well, the whole lot is not. The whole lot is pseudoscience.
Wait, what's pseudoscience?
Well, the whole lot is pseudoscience because it's been set up to measure something originally that isn't there.
Okay, that isn't the point.
Which is
listen, my friend.
Based on the pre-assumption that we are on a globe going around the sun in an offset elliptical orbit at a particular.
It has nothing to do with that. Okay, so wait.
Hold on a second. Remember, claim and support, right? So take a step back, both of you guys. Claim and support. So, Witsit, go ahead and make your claim. and then support it, and then Brian rebuttal. Thanks.
Okay. In a way, you're strawmanning me. I'm not claiming what they claim cause of gravity, right? My claim is this is measuring downward acceleration consistently, the velocity change within with a very intricate methodology of interferometry. So simply, I'm saying that this is measuring downward acceleration, the changes within, right? And that little BB that's dropping is inherently electrostatic. So that's an electrostatic acceleration that it's measuring.
Okay, but this is you're claiming it's electrostatic. How have you verified this?
Every compilation of matter that exists is electrostatic.
Okay, are you saying everything has electricity in it?
Electrostatics.
Okay, right. Okay. 1 second. Can I just share my screen a second? Okay.
Hold on.
Witsit, you're not sharing at the moment.
You'll have to let Witsit stop, and then you go ahead, and then I'll give you the go when it's up. Go ahead, Brian.
Okay, I'll wait for Austin to unshare.
Yeah, he already did.
Okay, I'm going to share them now.
1 second. 1 second. I said.
Okay, sorry.
Yeah, hold up, and then go ahead and share what you're going to share, because there is a little bit of a delay here in Skype for some reason. So go ahead and share what you want to share.
Okay, I have 3 things that are going to support me.
Pull up the first one.
First one.
You're good.
Definition of pseudoscience.
Yeah, go ahead.
Okay. Definition of pseudoscience. A collection of beliefs or practices mistakenly regarded as being on scientific method. Sorry, as being based on scientific method. So anything by definition that is not after going through scientific method is by definition is pseudoscience. Next one is this. All right, I have another thing to show after this. Okay, this is this just won't make sense right now, but it'll make sense in a few minutes. This is a mainstream claim. Okay, now they claim that we are living in what they call the homosphere. Obviously, we're not living in a sphere, but just for ease of explanation, this is what they say, and I'm not going to jump on the sphere part. That they say that the homosphere, the lower part of the atmosphere up to about 60 miles, in which there is no great change in its composition. That means that all the gases are homogeneous. They all mix together in one uniform way. It goes up to 60 miles of the atmosphere, regions, the troposphere, stratosphere, and mesosphere. There is no greater variation in the composition of gases. Contains a higher proportion of heavier gases such as nitrogen and oxygen. The gases occur in the form of the homogeneous mixture. The wind highly mixes up the gases. The gases show a higher reactivity. The heterosphere, okay, the upper part of the atmosphere, according to them, above about 60 miles, in which there is a greater variation in its composition, occurs above 60 miles from the Earth. Regions thermosphere and exosphere. There is a greater variation in the composition of gases, contains a higher proportion of lighter gases such as hydrogen and helium. The gases occur in the form of layers. The wind has less influence in mixing gases. The gases show a lower reactivity. What they're trying to say there is that above where the weather affects the gases and convection affects the gases, is that the gases naturally will layer as per their molecular weight or their density. That's what they're trying to say there. Now, I have been thinking this to be correct, that if you keep gases in several gases of different densities in a sealed container under the same temperature and left not messed with, left to be static, that they will start to layer. Okay. This will make sense in a moment. So I'm just going to show this. I got this off of an engineering site. Someone was asking this very question. Okay, does that happen? This guy here from General Electric, Yanbiao Wu, he was responded to somebody. He says, "Hi, all, glad to see your discussion here. I fully agree with Stefan." Someone else was saying something similar earlier on gas separation in the cylinder, especially when the molecular weight, sorry, my throat is going dry. Or my mouth is going dry. Molecular weight differs a lot. E.g., helium in nitrogen 2 and CO2. One of our customers met this issue after the cylinder was put in their factory for months. Then their laser machine kept warning them on wrong gas. That's because what was happening is the gases were after layering due to their density within the container, okay, within the cylinder. So that's why in our factory, when filling multi-gases in one cylinder containing helium-2 or hydrogen-2 or helium in air or CO2, rolling it is a must before its delivery to the customer. So he's saying that they must roll, if they have a cylinder in their factory that's been standing there for a while with gases in it of different densities, that they must roll the cylinder before they send it out, because the densities of the gases has caused, due to it being static, has caused a density gradient within the container. But the problem with this, why I'm using this, I'm going to unshare now. Why I'm using this, Austin, is gases are not affected by electrics or magnetics.
Objection, dude.
Hold on. Objection is stated. Go ahead. Witsit? State your objection.
Sorry. Yeah, he's straw manning me. I don't know anything about this, dude. I haven't even said anything about gases yet. We were talking about the gravimeter.
Yeah, but you stated.
1 second.
You not.
1 second, Brian. Hold on, Brian.
Yeah.
Witsit stating that it was a straw man. I was going to ask you, Brian, what is your claim? We'll get back to the objection here in a second, Witsit. Can you get, what is your claim associated with what you just demonstrated or provided?
My claim is that I'm showing relative density equilibrium happens within gases too, when they are left static and under a constant temperature.
Okay, is that it? No, keep it short.
No, it's that gases are not affected by electricity or magnetism, whereas Witsit said that all matter has electric charge, and he claimed that it's a static static charge, static electricity that's causing the upward and downward vectors, whereas this disproves that.
Okay. So you're conflating electrostatics and electricity. Those are not the same thing. So electricity is the hybrid of magnetism and dielectricity. The electrostatics and dielectricity are interchangeable. So you're consistently conflating electricity, which is the hybrid, with electrostatics. Those are not the same thing. You know, and that's why I went to the gravimeter, because we haven't even gotten to the actual crux yet, because I'm just asking, do you agree with the efficacy of the technology of the gravimeter?
Right. Witsit, stop. That is Brian. That was the initial claim. So I'd like to go back there to Witsit's claim right there, because that was the initial claim. Any problems with that?
About whether I agreed with the gravimeter being, do I have any issues with the gravimeter? What question am I being asked?
The technology itself.
Yeah, but the technology itself is flawed because it was designed for a completely different reason.
No. What's wrong with the technology specifically? I'm not claiming the cause of the people that go and run around talking about it. I'm talking about the technology itself.
Is it science or pseudoscience then, Austin?
It is scientifically valid. It's bulletproof because it is measuring the change in acceleration, and that's all I'm invoking it to do.
Okay. Yeah, but you're claiming. I just would like to get your claim. Like, please give me your exact claim on why you're saying things take a downward or upward acceleration.
Okay. So the gravimeter measures a variance in acceleration, a change in velocity, right, with this little BB. The Earth has an electrical field. There's an electrostatic nature to the Earth, and this acceleration varies in different parts of the Earth in the gravimeter, right? And that's because it's a variance within the field that the thing is dropping within. That's why I'm asking specifically, do you see any issues with the technology itself, right? Because it's very delicate and precise.
Yeah, I do. For a start, as I said earlier, there's two different gravimeters. There's an absolute and there's a relative. The relative is calibrated off of the absolute, and the absolute is basically it's using interferometry, and it's using an unnatural situation where something is dropped in a vacuum. We don't live in a vacuum, so it's unnatural. But the calibrated relative gravimeter uses accelerometers. Now, do you know the two types of accelerometers?
Real fast. I've already conceded it's an accelerometer. I'm asking you point blank, are you disputing the efficacy of measuring the acceleration, or do you agree that it's efficiently measuring the change in acceleration? Yes or no?
An acceleration of what?
Oh,
the little BB being dropped.
yeah, 1 second. It's a close-ended question, yes or no. Just ask it clearly one more time. What's it?
Do you agree that it's efficiently measuring the change in acceleration?
Do I agree that it's efficiently? This is the. Are you talking about the absolute gravimeter or the relative?
Yes.
Okay. Please, would you please just throughout the rest of this state which one you're speaking about? Not for me, but for the audience. You're asking me, is that efficiently measuring the acceleration of the BB that's dropped?
Correct.
Through a vacuum. Yes, they drop through the vacuum and they measure it with interferometry. Yeah.
Yes.
Yeah. It's definitely. It's not measuring it in standard units. It's calculated. In the end of the day, it's a calculation. So it's precise, calculatory. That's maybe the best answer I could give to you.
Okay, well, objectively, it is efficiently measuring the change in acceleration. This is a bulletproof technology, right? Now, their claim of the cause, I do not claim that. I'm not a crazy person. So I don't believe in gravitational fields, right? The Earth's electrostatic. There's a field. There's a variance within that field that affects the acceleration. The accelerometer or the gravimeter is measuring the changes within that acceleration.
Well, you might see it as a bulletproof technology. I don't. Because
would you like to specify contention, please?
Yeah, there's a problem there because there's two types. There's the absolute, then there's the relative. The relative is using accelerometers in the field, yes, gaining raw data. That's true, yes?
Okay. Sure.
Yeah. Can you please state, now I don't need the exact names, but can you please state the two different types of accelerometers, just how they work?
No, because you're dragging me through the mud, and I've asked you a point-blank question 5 times. Do you agree with the efficacy of the technology? Is it accurately showing us an actual change in velocity, yes or no?
Is it showing us it's not showing us anything. It's giving us a calculation in the end.
No, it's not calculating it. It's measuring with interferometry, like crossing patterns of lasers to measure the change in velocity of the BB.
Yes, but the interferometry is also using the speed of light.
We've already discussed this.
Yeah, but the speed of light is a calculation with it.
Yeah. Okay, stop. I see where this is going to go. This is going to go in a circling direction. So, Witsit's question was, do you agree with the observed effect brought to you by the gravimeter, whether it be the relative or the absolute?
Do I agree with the observed effect? I don't observe the effect.
But the gravimeter shows you the effect.
Well, I've never used the gravimeter. I've only learned about them.
All right,
so
let's say, and I'll hand it back over to Witsit because we want to move on quickly after this because we're beating this one to death. What he's trying to say, the observed effect via this piece of technology is it is measuring downward acceleration. It's a BB within a vacuum chamber, and they're measuring it many different places on the Earth. He's wanting to know if the efficacy is valid.
Okay. What they're measuring, what they're doing is observing an effect of something heavier falling through a medium that can't support it.
Yes, and that's what Witsit's asking you. Yes or no?
Observing that. We're observing a denser object falling through a less dense medium.
Witsit?
Yeah. We haven't gotten that far, right? I'm making sure that before we can move on, you agree with the effect is being accurately measured.
I don't. because it's not being measured.
So downward acceleration isn't being measured?
They're not. Are you talking about the absolute?
The relative. It doesn't really matter. Both of them are doing the same thing.
Accelerometers.
Okay.
We're talking about accelerometers. So it's using accelerometers in the field.
Do you agree? This is objective. This isn't even debatable. I'm trying to help you out here. This is objective, dude. It is measuring acceleration, dude. Downward acceleration and the changes within. Okay, objectively.
The relative or the absolute?
Okay, we're going. I'm going to stop it because we're going back and forth in the same direction. Right? The question is. Yeah, thanks. I didn't ask you. Stupid phone. Hold on 1 second, gentlemen.
No worries.
I start talking, my phone 8 feet away from me starts to answer. I ain't even asking a question, so shut up. So we're going back and forth between a relative and objective gravitometry. If I were to make up a word, all Witsit is asking you, I'm going to say this one more time, and then we're going to move on. And maybe we can't move on from this if this is his base point. What he's asking you is the observed effect. Are we observing the effect that it's showing us? Yes or no?
No, we're not. We're not observing it.
Okay. He said, Witsit, you got it?
Yeah, okay. Well, that's just objectively wrong. Okay, so it is objectively measuring the observable phenomena of downward acceleration. Now, no one in this debate is disputing that phenomena. We all observe it consistently. What the dispute is about is the causal agent.
I am disputing that.
All right, hold on a second. Let Witsit finish, Brian.
Okay.
Right. So, yeah, obviously there's not a consistent definitive downward acceleration. That's actually what the gravimeter demonstrates because it shows a fluctuation within acceleration, but it's objectively measuring the observable phenomena, the effect of downward acceleration and the changes within.
Done. Okay. Remember, gentlemen, when you're finished with your point, say done or finished so you don't overtalk each other, and please allow the other person to finish. Most of you guys are being concise for the most part, and I want to continue that. All right. So Brian, rebut.
Okay, Kiwi. Obviously, I don't agree with the claim of a downward acceleration, and I'm not trying to say that Witsit is claiming gravity. Right? That's not my point. My point is that I did ask Austin to define when he was speaking about the gravimeter, whether he was speaking about which one he was speaking about while he was speaking about them, whether he was speaking about the absolute or the relative. And why I've asked Austin to talk about, to give me the description of the two different types of accelerometers is because the relative gravimeter is using an accelerometer. I know how the both types of accelerometers work, and I know they have nothing to do with a downward acceleration.
All right, you done?
Yeah.
Please tell us the difference. This is going to help not only me, but the audience members. Please tell us the difference, you, Brian, the difference between the relative and the objective gravitometer. Gravimeter? Go.
Yeah, okay. The absolute is kept stationary majority of the time, mostly in one place. It is a big unit. It involves a vacuum chamber, a vacuum tube, a tube that's vacuumed out, where they're dropping, like when I read about it, they're dropping a mirror and using interferometry to calculate. They say measure, but I'm saying calculate the length of time it takes for this mirror to fall through this vacuum tube.
Okay. Now the relative one.
Yeah, the relative one is calibrated off of this absolute, and the relative one is used in the field. That's the one they can bring. It's a small one they can bring around with them, and that uses accelerometers. And that's using accelerometers, which is begging the question by the name accelerometer. That begs the question that there is an acceleration happening.
All right.
So accelerometers there is two types of accelerometers, and they're either using one or the other within those machines, and none of those have anything to do with acceleration.
All right, stop just for my education, because I do not know the difference between objective and relative gravimeters. Are you saying that the objective one, and this is just for me, sorry to interrupt, but I need to understand this myself. Are you saying the objective and the relative gravimeters are different conceptually?
Yeah, it's actually, for you, so you know, and for the audience, it's absolute and relative.
I'm sorry,
There's an
absolute and relative.
Yeah.
Are they different conceptually? You said the absolute has a vacuum chamber with a pebble dropping down through it. You're saying the relative ones don't use that same thing?
No, they're not using the same. They're not using the same system.
Okay,
They're
thanks.
not the same
Witsit,
system.
were you aware of that?
Yeah, that's not true. So the absolute and the relative actually both do use interferometry, the same thing. The relative is just a more portable device, and they go around and they go from place to place to place to place so that they can supposedly map out the difference in the gravitational field. But all they're doing is measuring the difference. So the only difference is that it's a portable device that they're moving to different locations to get like the relative acceleration to the location.
You finished?
Yeah, done.
Yeah. So we have an impasse here between knowing what the technology background of both of these machines. There's an impasse here, and I don't think we're going to resolve it here by arguing back and forth. Can we move on to another topic within the same topic, or is this a standstill at this point?
We can move on if I can just like conclude, so I can actually get to my point. This has been like kind of pulling teeth, and it's been very reiterative, but my point was simply that objectively they go out and they get a different rate of acceleration around the world in different locations, and so they claim it's for gravitational field, which is nonsense and is relative to mass. But we do see a difference in acceleration, and this is because the Earth has an electric field. There's a variance within that electric field of the electrostatic nature of the Earth, and so when you drop this all around it, you're going to get a variance in acceleration. That's what it measures.
Done. Do you understand what he's telling you?
Yeah, I understand exactly what's being said.
Okay.
Yeah. The problem is that they're measuring the supposed acceleration with accelerometers, and they don't measure an acceleration. That's why I've asked them to detail the two types of accelerometers that there is.
All right, maybe you're right, Kiwi. We can move on. I think that I've laid my point out pretty accurately. It's objectively measuring acceleration because something's dropping, going to the ground, and accelerating. They're using interferometry patterns to measure the acceleration and the velocity change within.
Yeah, but that's why we need to go through what accelerometers are and what the two types are. See, this is the argument, Austin, why things are taking a downward or upward vector. And that's why I brought up the gases earlier, because gases are not affected by any type of electrostatics.
Let's stick with that. Let's stick with that one. We're going to move on from the gravimeter, and let's stick with your claim, Brian. Please repeat that claim and say done.
Okay. Gases are not affected by electrostatics, electricity, or magnetism. They are completely unbonded molecularly, and they are free to move about, and they are not manipulative. They can't be manipulated only by temperature and volume of the container.
Done?
So that's manipulated.
Done?
Yes, sorry, done. Sorry.
Yeah, I know it's hard to remember that. Witsit? Rebuttal?
Yeah. Technically, that isn't true. Actually, you can use magnetic fields to push gases in certain directions. Gases also clearly they disperse omnidirectional. Right. They have infinite vectors, but with a strong enough field, it actually will not allow the gas to penetrate this energy field. You can replicate this numerous different ways with demonstrations. But of course, gas is let's say its velocity is so much greater than this very negligible bias that it's not going to affect the inherent dispersal of gas. But once again, you can in fact replicate that a magnetic field will not allow gas to penetrate it. Done.
So when you say a magnetic field, can you support that? Because are you speaking about gas or ionized gas, which is plasma?
Plasma is also affected by electrostatics and magnetism.
Yeah, I've never seen any gas being affected by magnetism ever. I've never been able to.
Okay, sorry, I don't have it pulled up, but I mean, I can send it to you or whatever. But yeah, you can actually demonstrate that if you have a magnetic field, it will actually cause the dispersal of gas to be relative to the magnetic field.
Okay, we have a magnetic field to the north, right? Now, I don't know what it is, or what generates it. I just know that there is a magnetic field to the north. Compasses point to the north. The north is where our magnetic field is. But that doesn't seem to have any effect that I'm aware of on the gases that we have in our atmosphere plane.
Well, perfect segue, actually. You're making my point for me right now. So we have a natural magnetic field on the Earth, which would actually affect the dispersal, i.e. the gradient. So we have a higher introduction of gas at the surface is a very big portion of it because we have more gases there and they're constantly being cycled here, so most of them don't leave the surface. But we have a magnetic field here. And like I told you, you can actually demonstrate that magnetic fields will affect the directionality of gas if strong enough. So it would be a logical deduction that since we have a magnetic field on Earth, it would have some effect on the dispersal of gas that we have here.
Sorry, as I said, I have yet to see any evidence that gas can be affected in any way by magnetism. And we have a magnetic field, and we also have gases behaving exactly the same to the north of us. No matter how far north you go, the gases behave the same as they do south. So there is no effect on the gases that we have in our atmosphere plane, let's say. There's no observable effect that this magnetic field has on these gases. And this is the most notable magnetic field we know of.
Okay, maybe this, most people, when we ask the globe zealots, we're like, can you demonstrate gas pressure without a container? And then their ignorant selves come around and they show us containers. One of the things they'll show you is within a container, if you have a magnetic field, that the gas will actually disperse relative to that. Have you never seen this demonstration that the globers run around? This is an actual demonstration that can be replicated. The magnetic field will in fact affect the gas, but of course it still has to be in a container to have the pressure, so they're stupid. But my point remains.
Are you talking about a fusion reactor?
Sure.
Yeah,
that's one of the demonstrations.
That's not gas, that's plasma. Ionized gas.
Okay.
I can tell you how it works. They fill the fusion reactor with a high density of hydrogen, and then they heat it to the point where it becomes plasma. And they have a toroidal field, which is a magnetic field, around the bottom of the reactor. And the reason is that they can only contain the plasma with that field, as there's no solid that they can put around the plasma, because the plasma is too hot and will melt anything they put around it. So they control the plasma at the bottom of that reactor with electromagnetism. But that's only when it's plasma, not as a gas.
Right, because it's a more condensed state. But like my point is that there's a logical framework here that we have in a magnetic field on the Earth. There's a resonance on the Earth, right? And so the density being the primary causal of the dissipation of gas, but you can only have a gradient in a closed dynamic system like we have. Like a closed system is the only way you can have a gradient. But to say that electrostatics plays no role would be intellectually dishonest, because you can't actually exclude electrostatics. We have a resting resonance, right? We have a magnetic field, and we know this. So again, just to clarify, my point here is gases are going to disperse in any and all directions, period, because its velocity is so much stronger, its energy is so much stronger than electrostatics, which is damn near negligible. But to just pretend that since it's weaker, it doesn't exist would be, not particularly efficient.
Well, I never said that it didn't exist. What I said is there was no evidence to support it causing a downward or upward vector of matter. That's what was my point. And that's why I showed the video at the start. And I asked you those two questions about Anthony's experiment and about whether he proved his positive hypothesis or not. So
no,
I never said that. I actually have a video on my channel showing how the ocean's movement is caused by a magnetic field, electric charge, and convection. So I don't deny that at all. I just deny that there is evidence to support a downward and upward vector. Done.
Okay, so again, I said this at the beginning, that if you manipulate the density of the medium, the effect that has, the energy that's resultant of that, is so much stronger than electrostatics, which is very negligible. We can demonstrate this through experiment, okay, like on the smallest scales that we can replicate. There's a resting electrostatic potential to everything, like even these subatomic particles that I don't necessarily agree with the material nature claim of, whatever. So the point is just that it is there. Okay, and that's what is inherent or intrinsic within the downward bias. We have a natural up and down. Now, typically flat earthers just say, well, there's just an up and down, and that's all that they say, but they don't ever address why. But you're claiming, inherently in your claim, what you're saying is that the only causal relationship is relative density, and I am clearly stating that cannot be true because everything is inherently electrostatic. So that means it also plays a factor. All you're doing is manipulating the control variable of the density of the medium.
Done?
Yeah, but see, the thing about
Yes.
it is that we can show, I can show, anyone can show demonstration of this. How when I'm walking, if I jump off a wall, right, I won't, I will go down as my density is more than the gases around me, so I land on the ground. If I jump into water, my density of my body is more structurally supported than it will be if I'm jumping through gas. If I jump onto a solid, it will, like the ground, it'll be totally supported. So there is a natural support for matter given by matter. And even with gases within a steel container, it still happens that the less dense gases will end up rising, right, up towards the top of the container, and the more dense gases will be at the bottom, because the more dense matter has better structural support. So, I mean, I can show this. Like Anthony showed it. This is a constant in our world. It's constantly happening. This density, it happens to gases, liquids, solids. I mean, the water cycle is a great example of it.
All right, finish out your point. What's the claim with this one?
Well, my claim is that this is a natural thing that happens all the time within matter, whether it be gases, liquids, solids. That structural support happens. Density gradients happen due to structural support. That all matter needs structural support from more dense matter.
Okay.
That's my.
What's it?
Yeah, so once again, density is not being disputed to play a factor here. I've already conceded that it's very, very prominent in the actual effect. And this gets into a more complicated technical discussion, which is what is weight, right? But really what we call weight, or the downward acceleration, it's relative to a variance of factors, not just density. It's relative to the vector, it's relative to the coherency, it's relative to the location. So it's many factors. And when you just talk about density, you're not discussing the entirety of the phenomena. You're only discussing and manipulating and varying the control variable of the density of the medium. This is not the entirety of the explanation of the phenomena. I also can screen share where oxygen is affected by magnetism if you would like to see it.
Hold on would you like to see that?
Yeah, sure, absolutely.
Go ahead, Witsit. Tell me when you're ready. And I think I already got it. 1 second. You are up, Witsit.
All right. So as you see here,
before we start, what did you just say there in the last? Because you said several different things at one time, and I missed. I've only got some of it. Before you talked about the oxygen with the magnetism. What was it you said previous to that?
Yeah, that wait.
Just before we go on to the video.
Okay.
If I say to you, tell me if you agree or disagree with this. So, an object's or substance's weight is caused by its inherent density found within the confines of its volume. Would you disagree with that?
No, that's a very big factor, but that isn't all of it.
Okay, but can you show manipulate? Can you show a demonstration of your claim?
Yes.
Okay, you can show you can show not just a piece of paper being affected by electricity that's been added to it. I'm talking about in the natural world.
Okay. So you just asked me what my claim was, and then you started arguing against it. But yeah, weight or acceleration is relative to many things. Density is one of these things. So the way we all agree with this one, right? We can demonstrate this one. A 5-year-old can't push a sumo wrestler over, but when they get in a pull, she can push him because you manipulate the density of sumo wrestlers in, right? But also coherency is one of the things that I said. So everything's incoherent if it isn't coherent. This is the molecular alignment of an object. So if I take a magnet, which there are naturally occurring magnets, right? Lodestone, for example, and I drop it to something that's metal, it's going to accelerate way faster. The only thing that was manipulated was the actual coherency of the field. This demonstrates objectively, irrefutably, that the coherency of an object will directly affect the acceleration rate.
Yeah, well, I mean, the density of whatever object it is, if it's steel, it's going to accelerate pretty fast, more than a feather. You know what I mean? A piece of steel will fall faster than a feather, for various reasons. Obviously, the feather is shaped different. It can wind air resistance and all that with the feather will cause the feather to go slow. But if you if you make that feather into steel, it will fall very fast. So that's true. I totally agree. You know what I mean? I don't have disagreement with that, but your claim, I'm not seeing you demonstrate your claim. That's the problem.
I just told you how you can demonstrate it. I said that if you okay, for example, you know how to make a magnet, right? It's incoherent before you make it a magnet, right? And you can go like, this isn't natural. Well, that's why I told you there's naturally occurring magnets also. Okay, this is a naturally occurring phenomenon. But like if you use molten metal or you introduce voltage, you can align the molecular alignment of them, making it a magnet. So if I take the neodymium iron boron piece of metal, right, and I drop it, it's going to fall at a certain rate. Then I introduce voltage to it or molten metal, and it now makes it coherent. It's going to drop much faster if what it's dropping to is metal or has metal within it. This demonstrates objectively that we've manipulated and varied the factor of coherency, and that has affected the acceleration rate. So I told you that weight was relative to a handful of things, one of them being coherency. You can practically demonstrate this.
Hang on. Okay. What is coherency? Please define that.
Okay, so it's the molecular alignment of the object. So if something's incoherent, it's basically, let's say, discombobulated. It's going in any and all directions, right? That's how you make a magnet. You put voltage into it, it's going to overpower the resting resonance of the magnet. It's going to align the molecules all in the same direction that you introduced the voltage to because it's stronger, and that's how you make a magnet. So you've increased the coherency of it. Now it's coherent. Magnetism is falsely attributed to just being coherent, but there's also incoherent magnetism because everything's inherently magnetic or electrostatic. So coherency has to do with the molecular alignment.
So are you saying when you make a piece of metal, so this is what I'm trying to get, right? Right? There's two problems. I'm just going to work with this one for a second. Are you saying that when you add magnetism, you speed up the acceleration?
Yeah.
Right. Now I understand. Now I get it. Right.
Okay.
Right. But what has that got to do with reality? How, like, what you're doing there? I asked you earlier whether the Earth had a constant positive or negative charge, and you said no. So what
did I say, Brian?
What did you say then?
Yeah, I said that even if something's neutral, it has a resting electrostatic potential. The Earth is the dielectric plane. So even at neutral, it still has a resting electrostatic potential.
Okay, so you're saying that the Earth doesn't have a constant positive or negative charge to it?
I'd say that it's the dielectric plane or inertial plane. Yeah, it's people would call it neutral in academia.
Well, if it's neutral, then it doesn't have either. So there's no reason for something to be attracted to it.
If something's neutral, it still has a resting electrostatic potential, though.
Yeah, but potential doesn't mean definite. Like if I take a bar magnet that has a positive and negative side. I hold the negative side to the floor and I drop it, it will fall to the floor. If I take it up and turn it around and hold the positive side to the floor and drop it, it will fall to the floor. So if there was a magnetic effect, then either the positive or the negative would be repelled. But we don't see that.
Okay, I've once again explained that actually the Earth's dielectric, it's neutral, and that there's no such thing as repulsion and attraction. This is a misnomer, right? Like when magnets attract to one another, they're not attracting, they're accelerating towards the null pressure point because each magnet is putting out an energy field and it's mediating the pressure relative to its energy field. And so they're going to accelerate to the null pressure between it. But the Earth's a resting electrostatic potential, which is my entire point. It's damn near negligible, but intellectually dishonest to dismiss it entirely. You can't just hand wave dismiss it because it's still there. So if an object falls to the ground, it's electrostatic, the Earth's electrostatic, so inherently the acceleration is electrostatic. Static meaning, of course, still, right? Not moving, stationary. But once it starts to move, it's no longer still, it's accelerating. The motion increases the energy output. Done.
Okay, but this is the problem. You're saying it's negligible, and then you're trying to so you're saying it's a negligible thing, until someone leaves something fall, and then suddenly there is a positive and negative attraction happening downward.
I said damn near negligible, and yes, that's objectively true, because as you increase the acceleration, it's no longer static, it's in movement.
Yeah, but your claim is that everything has this thing in it, and when we leave something go, it falls to the ground, and that's because of an attraction. Yes?
Well, yeah, because electrostatics, like incoherent magnetism, is still attractive. Like no matter what, incoherent magnetism, which is the same thing as electrostatics, okay, it's always attractive. I can demonstrate this also, but we're still trying to get to the other demonstration I was going to show you, right? But like we can demonstrate this as you increase the quote unquote mass, which is conceptual abstraction, reifying gravity. We all know mass is nonsense. But as you increase the incoherent mass, it actually has a disproportionate effect on the strength of the pull, meaning as it gets bigger, it gets weaker. They inverted this so they could tell us that planets revolve or whatever. But we can demonstrate this by increasing the mass of incoherent magnets.
So you're saying that when something is being let fall, that there is an attraction towards the ground magnetically.
Yeah, once again, that's what creates the bias, but it's a damn near negligible because electrostatics is so weak because it's incoherent, it's discombobulated, it doesn't have molecular alignment.
Well, then it's not connected to the vector of up and down then.
It is inherently, because incoherent magnets are always attractive only.
But
We can demonstrate this. I have a real issue where flat earthers go around and say, well, we need to practically demonstrate things. We need to practically, but my practical demonstrations are currently being hand wave dismissed. I can practically, this is what science is, right? I can practically demonstrate that as you increase the mass of an incoherent magnet, more so the matter compilation, it's going to become weaker. We can demonstrate this.
All right, I think this point has run its course. Witsit, you wanted to show something here. Could you go ahead and reshare, and then we'll get to that point? 1 second. You are up.
All right, so this is the paramagnetism of oxygen. We'll play through it. So here we go. We have oxygen. Now we're going to introduce it to a magnetic field, and the gas is actually going to act relative to the magnetic field that's encompassing it. So to say that magnetism has no effect on anything but ionized plasma is not true. So as this changes its state to oxygen, we will see that in fact the very magnet itself affects the oxygen.
1 second, Witsit. Allow Brian to catch up because it's lagging for him. Let us know when you see this, Brian.
I can see it on screen now, Kiwi. I don't see. Could you tell me what's happening here, Austin?
Yeah, again, the magnetic field here is going to directly affect the dispersal of this oxygen, as you can see where I'm pausing it and bringing it back so you can catch up.
So there's a phase change here happening, is there? From
yes, I already said that.
What's being poured? So it's a liquid oxygen, is it? Is that what you're saying? It's being poured, and there's a phase change happening.
Yes, this is oxygen condensed into a liquid form, but then as it turns into its gaseous state, the actual magnet itself will affect the dispersal of that gas in the gaseous state. This is a practical demonstration. So,
well, what is it doing to it?
It's not allowing it to disperse freely because the magnetic field's having an effect on the oxygen.
Okay, can we just go back a little bit on the video again, just to see it again, please?
Yeah.
If you don't mind. Yeah, could you just go back to see it so you can see the whole apparatus, please? I just want to see the whole apparatus, not just the two, not just the positive and negative, the whole lot with the guy there, if you don't mind. I want to be able to see the whole lot.
It's hard to narrate it live time with your delay, but like, so.
I just want to see, if you just go back, I just want to see the whole lot because The problem here is that what I see happening is that the phase change is not happening correctly. That's what's happening there, because we can't see.
Witsit, go on mute.
It is dispersing. I mean, when you were showing that there, it was dispersing. I mean, it was dispersing. We can't see. It was in a denser form. It looked more like condensed water vapor. Water to liquid, like condensed vapor. Sorry, not water vapor, but condensed vapor. That steam there looks more like condensed vapor. We can't see oxygen. So what's happening here is it's affecting the phase change. The magnetism is affecting the phase change. That's what I see happening there.
Okay, so you see that it's actually causing it to loop back down around. This is what magnetic fields do.
It has
so you can't see the magnetic field either. But look, as oxygen gets more and more into the gaseous state.
Okay, hold up. Brian, let Witsit finish his point. He'll say done, and then you can rebut. Go ahead, Witsit.
I apologize.
Yeah, so as this is turning into the gaseous form, as opposed to just going in all directions upward, right? Like the magnetic field, which is a toroid, as we all know, this is actually causing it to loop back down. So this is showing that magnetism can affect a gaseous state.
Okay, are you done? Can I go?
Yes.
Yeah, done. My bad.
Okay. Yeah, well, I don't see that happening here. What I see here is the phase change is being affected by the magnetism, whereas the liquid is becoming a vapor, and then it is phase changing into. That's why I wanted to see all the apparatus as it was happening, but they're just showing this one area. They're not showing what's happening to all of the let's call it oxygen vapor that has gone down the way. The reason it's going down at all is because it's not after phase changing yet, because gases don't have a downward vector; they have a vector in all directions. So that's still a vapor. So what's happening here is the magnetism is affecting the vapor, because magnetism will affect fluids, can affect certain fluids. Yes, I agree with that. But what I see here is it's just affecting the phase change of oxygen.
All right, what's it?
Hold
on, Brian. What's it? Rebuttal.
Yeah, so of course you're right. It would have more of an effect in the liquid state. It's a more concentrated form of the matter. But we know that this is in lifetime turning into oxygen in this gaseous state. Now it wants to go up, but this magnetism is actually causing it to stay concentrated in a toroidal manifest or form of movement around the source of magnetism. It's right there. We're all watching it.
Well, I'm not seeing oxygen. I'm seeing a vapor, because oxygen we can't see. Excuse me. Oxygen we can't see, and oxygen moves in all directions. You're not affecting oxygen. You're affecting the phase change, not oxygen.
So are you effectively saying that there would be no way to demonstrate it then?
Well, there isn't, because it doesn't happen.
All right, all right, hold up. Let's round out this point. I think we beat this one to death. Let's go ahead and round out the point. Witsit first, and then Brian, quick rebuttal, and then on to the next claim, or finish up, and I'll leave that up to you, gentlemen. Witsit first.
Yeah, simply I'm just showing that. Sorry, I stopped screen sharing. Yeah, so. Of course, the only way that you could actually attempt to practically demonstrate this was to take it from the liquid state and then have it to change, right? To just say, well, since you can't see oxygen, then we know it's not happening is intellectually dishonest. We're watching it change to the gaseous state right here, and in the gaseous form, in the process of change, it is clearly not allowing it to disperse in all directions as it wants to, or even fall down as it wants to. It's making it loop around the magnet, and it's continuously turning into the gaseous form. He continues to add the liquid just so that you can continue to see the process.
Brian, short rebuttal. Yeah. Witsit will have the final word after you.
Yeah, okay. For a start, no, I am not being intellectually dishonest. I am just detailing exactly what knowledge I have and what I see. What I see there is a phase change being affected by magnetism, and I see a very small amount of the vapor around where the two magnets are nearly meeting. That's what I see. I see the rest of the vapor going down because it's a vapor, and then it is turning into oxygen, but we don't see that because when it turns into oxygen, we can't see oxygen. That's what I'm seeing there. I'm not seeing magnetism affecting oxygen, as that is the practical demonstration for real life. That's what you would have to show, because I can hold a magnet up in front of me here, and it won't affect the oxygen in the room at all. That's what you need to demonstrate. So that's the thing. You need to demonstrate that to prove that magnetism can affect gases.
I agree we should move on, but just to clarify, what you're basically saying is it's impossible to demonstrate it because you can't see it, so that when we see what's happening when we can see it, we know it's affecting it, but that when you can't see it, everything changes and it's no longer affecting it. That's your claim. So I disagree.
Objection.
Objection?
Yes.
Good.
Yeah, I would like Austin to repeat exactly what he just said there.
You can't.
Yeah, so basically you're saying we can see that it affects it during the change to the gaseous states, but what you're claiming is that when oxygen becomes oxygen entirely and you can't see it, that effect is no longer taking place. You're just claiming that the phenomena stops as soon as it becomes oxygen and we can't see it anymore, right? So I just disagree with that. We're watching it as it changes to the gaseous state, being literally spun around the magnetic field.
Okay. The reason I said objection was because I didn't catch everything you said.
Okay. Quick rebuttal, Brian, exactly. and then Witsit will finish this point out.
Okay. What I'm seeing, one more time, I'm being completely honest. I'm not seeing oxygen. I'm seeing a vapor, water being affected. Liquid oxygen being affected by in its phase change from liquid oxygen to the gas of oxygen by a magnetic field. But I'm not seeing it stopping it. I'm seeing it affecting it as it's slowing down. It seems to be slowing down the phase change. So there seems to be more vapor hanging around. But then that is turning into the gas of oxygen, because the vapor is going down due to its density. That literally is literally proving my point of density. Is the denser vapor is going down, but when it becomes gas, it just fills the available volume.
Okay, is that it?
Yeah. Okay.
Final, Witsit, your final thoughts on this subject, and this ends this claim. Go.
Yeah. No one's disputing the effect of directionality based on density. This is once again not being disputed. You just keep saying that, but you're skipping over the effect of the magnetism. And of course, I'm showing you, I didn't say that it stops it. I said that it affects it. You said that magnetism can't affect gas at all, and I showed you that it clearly can. With a demonstration. So that's just where I'm at with it. I said that it affects it. I said it's just a small portion of the observable phenomena of a gradient.
Done?
Done.
Brian, any more claims?
Yeah, I would like to speak about the phases of water, ice, water, and water vapor.
Make your claim and then support it.
What my claim is going to be to support. I could only just bring up exactly what I'm saying, more or less. So, if you want, I'll do that.
If you're going to make a claim, hold on. If you're going to make a claim, you need to support it. Are you going to need screen share in this?
No, I mean it's just going to be explanation of those three phases.
Okay, go ahead.
Yeah, okay. We have the three phases of water. We have ice, we have water, and we have water vapor. Ice floats on water because it is a solid, but it's actually less dense than the liquid of water. This is for a very good natural reason. What people don't realize is what the ice actually does is, even though it makes the water that's directly under the ice very cold and obviously very dense. So the water underneath the ice is normally a lot more dense than the ice itself. But what the ice actually does in colder regions and over lakes and stuff is it actually creates a covering that creates what's the word I'm looking for? An insulation. So what happens is that marine life, what they actually do is they actually start in the colder months. They actually start to feed, and what they feed on lower at a deeper depth. But that water that's down there that would normally be colder is actually heated up, and they actually feed on this less dense. What actually happens is that because the water down further is being warmed up, what's happening is it causes convection within the water because the heat rises, becomes cold underneath the ice, then it drops back down and it heats up again. And the ice actually is a natural barrier that actually allows the marine life to continue being life, because it allows the marine life to drop down lower to a place that wouldn't normally have been there in the summer months to feed and to live, because it creates an insulation. That's one of the main reasons why ice floats. Now, water itself, we can walk on ice once it's thick enough. We can walk on ice. It's a solid, but it's actually not as dense as water. So because water is a liquid, we will only float and swim in water and whatever else, right? It's more got to do with your volume and how you spread yourself out and all the rest of it. But water then is evaporated and becomes water vapor. Now, water vapor is less dense than carbon dioxide, argon, nitrogen, and oxygen. It's less dense than all four of those. And what happens to water vapor is it naturally, right, even though it becomes part of the homogeneous gases we have, it naturally will reach up higher. And when it does, it then does condense. Some of it will condense and become clouds. Because if it didn't rise up, we wouldn't end up with clouds. If we couldn't get enough water vapor up there, we wouldn't end up with clouds. And the other thing it does is that it is converted into oxygen and hydrogen through a process that, as far as I remember, it's called photo dissociation, where the sunlight breaks up the compound of H2O into 2 hydrogen and 1 oxygen molecule.
Brian,
and so
Brian,
sorry,
round out your point.
My point is that these three phases of water have very different densities and very different forms. But for if
Brian, stop.
Naturally,
Brian, hold up, Brian. Brian, drop from the call and rejoin, please.
And it is the reason for up and down.
Brian,
of matter. Yes.
Drop from the call and rejoin, please.
Yeah, okay.
1 second, Witsit.
No worries.
Me?
Radio check.
Hello? 1,
Yeah.
2, 1, 2.
I got you now, Brian. Summarize your point very quickly so we can get to Witsit.
Yeah, okay. My point being is that the density differences between water vapor, and ice is a completely natural thing that has to be there for life to be as it is in our world.
Okay, thank you.
These densities are part of relative density equilibrium.
Okay.
And that density
is that
the reason.
Is that the end of your point, please? We're gonna have to round this out, Brian.
Okay.
You got, listen, both. You got to be concise. Don't go on long monologues. Be concise as possible. Witsit.
Yeah, I'm not sure what I don't know what he's arguing against. I don't dispute the effect of relative density, so I'm not sure what that was
Roger
arguing.
Brian?
Yeah, well, my point being, if I just use water vapor, for instance, that water vapor is less dense than the gases that make up air. And so water vapor will eventually, even though it's part of the homogeneous mixture, it will eventually rise up high enough to condense and become clouds. And that is a natural process. That the density, that it's a part of a natural process.
Right. I don't think Witsit will claim anything other than that. What's the underlying point as it relates to downward acceleration?
Well, how can Witsit prove that water vapor is rising up for any other reason other than its density?
Well, I've already said that density is going to have a much stronger effect. The relative density, how it affects directionality, is much stronger than the damn near negligible effect of the inherent electrostatic nature. No one's disputing relative density.
Brian, quick rebuttal.
Yeah. Okay, but Austin, is your claim not that the reason for up and down is electrostatics?
Yeah, the natural up and down is inherently, it's intrinsic that electrostatics is related because everything is electrostatic.
Okay, and how would you demonstrate that?
Well, you would have to actually provide, I made a very bold claim there, right? Everything's electrostatic. You would just have to provide something that isn't.
Well, it's not up to me to provide evidence for your claim. I mean, it's your claim that electrostatics is the reason for the directionality of a downward or upward vector of matter. My claim is purely density.
Okay. So can I guess I have to screen share again?
1 second. Go ahead and screen share. I'll give you the go when it's ready. You're good to go, Witsit?
All right. So I'm sure a lot of people have seen this video, but...
Okay, sorry, I'm seeing this now. I'm seeing this on Skype now. I wasn't seeing it before. Just to let you know. Okay, here.
Okay, so what we're going to do here is we're going to actually increase incoherent mass, which again is just conceptual reification of gravity, but just for intents and purposes. As we actually increase the amount of matter that's incoherent, the quote-unquote pull, it gets weaker, but it still remains attractive. So this is showing you, which of course incoherent magnetism and dielectrics is the same thing. They're intrinsic. As you increase this compilation of matter, it remains attractive, but it gets weaker. We're measuring this right here in the demonstration. So it shows that it's always attractive. Always. Every single time. Both sides of this magnet, both sides are attracted to this incoherent mass. And so as you increase the size, it gets weaker, but it remains attractive only. And again, everything is electrostatic, including the Earth. So you would have to say that this phenomenon just gets thrown out the window when it comes to the Earth, even though it can be practically demonstrated. Done.
Brian, rebuttal.
Okay, what I would say about this is more of a debunk of what they call gravity, what the ballers would call gravity. There's more of a debunk of what the ballers would call gravity, but it doesn't show how a directionality, how it explains a directionality of matter, either a downward or upward vector. It doesn't replace relative density equilibrium as a valid explanation, because it doesn't show downward or upward. It just shows that it debunks basic gravity.
All right, Brian, that's it. Is that Witsit? Go ahead. Yeah. Rebuttal.
Yeah, no one's trying to replace relative density. I don't know why we're like an hour into this and this is being misunderstood, right? Like no one's replacing relative density. That is not the objective here. The point is that this is attractive only. So if something falls to the ground, right, and it's electrostatic and it's falling to an electrostatic resonance of the Earth and it's attractive only, then that would indeed affect the downward bias that we have on this plane Earth that we live on.
Brian?
Okay. Okay. If you just go back to where you were just showing a minute ago with the ball bearings and that, are they magnetized?
Well, it depends. Yeah. No, not in the sense of coherent magnetism, which again is a misnomer.
Well, they look like they're being attracted to each other there.
Thank you. That's my entire point. They're incoherent, but yet they still attract. And as you increase the matter, it gets weaker, but it remains attractive only.
Yeah, but the point I'm making is these are magnetized, are they not?
No, they're not coherent magnets. They're incoherent mass.
So I can get several ball bearings and I can put them together and they won't try and stick together. So how come those ones are sticking together?
Because they have a natural electrostatic charge, but they're not coherently aligned. So that's why when you increase the mass, it gets weaker and weaker and weaker because you're increasing the incoherency of the matter as you add to it. But it's still electrostatics inherent in this, which is the same thing as incoherent magnetism, dielectricity. It's going to always attract it.
Yeah, but are they in any way magnetic?
Every compilation of matter is technically magnetic.
Okay. Now, right, hang on. This is my point, you see. They already have some form, they already have been magnetized in some way. They may not have a constant positive and negative, but they already have been magnetized in some way. Otherwise, they wouldn't be doing that. That's not analogous to what we see in reality. I mean, my point is that it's a false equivalency.
Witsit, rebuttal?
Yeah, it is analogous to what we see in nature because everything that we see in nature, and I mean literally everything, is electrostatic. Everything. You cannot name one single compilation of matter that I can't rub my feet on the ground and go touch and it transfers the electrostatic charge. Everything's electrostatic. This includes the Earth and any compilation of matter dropped to it. So yes, it is perfectly analogous to everything that we observe in nature.
Brian, rebuttal. That'll be the last rebuttal. Witsit will close this point out. Brian.
Okay. Yeah, I can rub my feet on the carpet or rub the cat, one of the cats, and create a static electric charge. But it's me doing that creates the charge. It's like these are phenomena that I'm not denying, but I just don't see how we have any support here for the claim that this is causing a downward and upward vector of matter. I'm not seeing it.
Witsit, close this point out, and then we'll move to the next claim.
Yeah, once again, because anytime you drop something to the earth and it falls down, what you drop is electrostatic. The ground is also electrostatic, although damn near negligible. It does have an attractive quality, right? That's why when you manipulate the density or something, it overdoes it. It overpowers it because it's so incredibly weak. And the earth, as you know, is very big. So it's a very big incoherent mass. So it has a very weak attractive quality. But nevertheless, all incoherent matter is electrostatic and thus also only attractive. So everything that we drop to the earth has an electrostatic attraction or acceleration. So.
All right. Thank you, gentlemen. Are there any more claims left? Brian, claim?
Well, but I don't really have
okay.
claim, just maybe a final thoughts.
Yep. Thank you. Witsit, any more claims? Just final thoughts?
Yeah, that's all, guys. Fine. That's all the claims I have. It's very simple, right? Like
one second
phenomena of downward.
1 second, sir. We're going to close out. Brian went first before, and you went last. Correct? Witsit. Go ahead, sir. Final thoughts, 2 minutes each to restate your positions and summarize. Sorry.
All right. Cool. No, that's my bad. So yeah, I mean, I feel like my point is very simple. That's why the chat is so frustrating to read. I'm just going to stop reading it. But I haven't asserted anything without demonstration. I've showed demonstration for all of it. If you increase incoherent mass, then it actually is disproportionate to the attractive force. It gets weaker. So we can practically demonstrate this. In fact, you'd have to hand wave dismiss the actual practical demonstrations that I've provided as if they're not analogous to the Earth. You simply cannot do that because the Earth is matter. What you drop to the Earth is matter. Everything that's a compilation of matter is inherently electrostatic. Static meaning not moving, but of course, once it accelerates, you increase motion, which you're actually increasing the energy input or output of the object falling. So everything in existence that's naturally occurring is inherently electrostatic. That means everything that accelerates to the Earth is also inherently electrostatic, more specifically dielectric, which comes full circle. What's been misidentified as quote unquote gravity is nothing more than incoherent dielectric acceleration, and it's very, very weak.
Thank you, sir.
Done.
Brian, 2 minutes. Final thoughts, summarize.
Okay, thank you, QE. Okay, I have not seen any evidence tonight that is analogous to reality. I haven't seen any demonstrations from Austin that weren't a false equivalency to support his point concerning nature. We can see he doesn't disagree that relative density equilibrium is the thing, I don't think, but he's agreeing with that, but then he's stating that this other thing, electrostatics, is causing a downward and upward vector. He hasn't explained the upward vector part, and his explanation for the downward vector, there isn't enough meat on the bones of that. There isn't, you need to come back with more for me to accept that. So relative density equilibrium, as far as I'm concerned, and as far as I can see and find out, seems to be a law of nature. that we can show with scientific method. We can show that it does happen. So I don't know. I don't really know what else to say. It hasn't changed my mind in any way. It's actually confirmed it more for me. Thank you.
All right. Thank you, Brian. We're going to move to, and this appears to be a short after show on questions. Like I said in the beginning, if you have a question for any of these two gentlemen, the time is now. Super chat, and I will ask the questions to each gentleman individually as they were received. Please address it to either Witsit or Brian, so it's clear for everyone to see and hear. And we have 1, 2, 3, 4 comments. 3 comments from one person, Theo Megawordy. And these don't seem like questions. So his first one: for there to be a force of down as an acceleration, doesn't that mean there's a needed balance upward acceleration as initially claimed in relativity? That's his first comment. He didn't put it out to anyone, so neither of you gentlemen have to answer this one or the next one. Down only exists on flat Earth. Globes need inward. That's Theo Megawordy. And his last comment: wouldn't ever-present downward acceleration lead to increasing weight, needing ever-present upward acceleration to balance it? Smells like relativity. And the last comment, Unicorn Laser Eyes, great time, very interesting. Thanks, Unicorn Laser Eyes. I really appreciate that. So I'll give you another 60 seconds for anyone in chat to ask these gentlemen a question. First, I'd like to thank both Witsit and Brian. Listen, there's a couple places where it got a little heated, but overall, outstanding performance, gentlemen. This was easy for me to moderate. Only a few occasions where I thought I needed to butt in. Maybe I was wrong in that, but I wanted to nip it in the bud so we can conclude. But overall, gentlemen, my hat's off to you. Outstanding. Outstanding performance.
Great job moderating, bro. Breath of fresh air.
Appreciate it. I did my best. It was the first time officially in this capacity. I enjoy it. I don't enjoy it as much when I don't understand everything everyone says. So it was good. I like I said, I really enjoyed it, and maybe we can do this in the future. As of right now, it doesn't seem like I'm getting any more. We got Theo Megawordy. Gravity with a B / downity, non-contingent to shape of the Earth. So that's his next comment. You guys are getting left off the hook here. That's what it seems like to me. Come on. You guys don't have any questions or comments you'd like to make to these two guys? No?
So maybe I should super chat a question for Brian.
No.
Yeah, get one in there.
No, do not.
Kidding.
No, that's cheating. And I'll have the bailiff whack your, you know what?
I guess I need to go to my sock account just a sec.
The bastion of integrity.
I'd just like to say, if it's okay, QE, thank you for putting this together. I know that I approached you with it and that it was a bit of hassle to do, but I appreciate that you did it.
Yep.
And thank you to Austin for turning up for the debate, and not for turning up, but for agreeing to the debate, as this was needed. Thank you.
Outstanding. Thank you. Any last words? What's it? And I'm going to round it out.
No, just, the crux of my whole thing was the gravimeter shows different accelerations all around the Earth. So if you're just going to not explain that phenomenon, I find it dissatisfying. All right, there's a change in acceleration relative to the electrical field that we know exists on Earth. That's my take. I haven't changed, but that's about it. Thought it was super cool. Great moderating. Thanks for showing up. I think maybe we should do flat for flats more because it's much more informative and productive than any globe zealot that's just screaming their vain religious superstition.
Yeah, thanks. Thanks to both of you guys. I couldn't agree more. I am tired of it. Oh, we got one more. I'm going to take you guys off mute. We have the Adam Meekin. I demand a Supreme Court investigation into moderation of this debate. Other than that, great show. The three. I'll tell you what, I should have read that first, and then I went and kept the show going. So, again, thanks to Witsit and Brian. Again, outstanding performance. We'll try to do more of these in the future. It just depends on who wants to debate, who can stand up and give account for their position. So I'd like to thank everyone for coming. Have a great day. And you know what? Take no prisoners. No quarter will be asked. None shall be given. And remember, I'll be back.